Good evening. So it's about discourse analysis. So discourse analysis, maybe a couple of words background. It used to be area of like very specific linguistic standalone, really like elite group of linguists and not connected to anything. Gradually, it is becoming computational. So computational to a degree. People, mostly universities, build discourse parsers, but still it's pretty much virgin area in terms of application. Overall, I'm not even talking about industry, even linguists mostly don't have idea how to use it. That's why I think it's important to focus. So two main parts today. So just a brief formula. What is a chatbot? Chatbot is a sum of search engine and discourse management. So search engine has to be good. But unlike like web search engine, we don't have this luxury of learning from million of previous questions to know which answer is correct. So we need to, in double quotes, understand something from user query. How it is different? Like Google, if you ask question, what is the best restaurant in this area, and when do I send taxes, Google doesn't have to really understand what are taxes and how to send, about sending. It's about million people and maybe 100 million people, billion people asking the same questions, and then Google knows which answers people choose. And for chatbots, we cannot do it because it's personalized. Like I'm talking about my bank account, and I have account different from your accounts. So we don't have this luxury. So instead of not knowing linguistic, but learning from what other people asked, we have to deal with some linguistic. We have to at least treat it at syntactic level. That's number one. And here I showed, and to solve this problem, instead of dealing with keywords and their frequencies, we don't have enough data, we don't have enough frequencies, and data is very frequently random and noisy. So we have to deal with individual situations. So instead of keyword frequency, we deal with parse trees. And we do linguistic analysis, similarity based on parse trees. That's number one. Now, chatbots. So there's a very popular, throw a lot of customer support logs at chatbots. And I'm going to talk, there's a lot of issues with this approach. So instead, what we're saying, we have to learn how intelligent people organize their thoughts in conversation, not necessarily typical millions of customer support agents. So it's not about getting huge noisy data, but at least it's building about some kind of nice model. That's why we need discourse analysis. We need to be able to formalize how people organize their thoughts independently about the topic of conversation. Because there are millions of topics, but the ways how people organize thought is limited, luckily for this approach. So a lot, I'm going to quickly run, but so in general, the slogan here, there's a lot of disattachment between how chatbot really works and how people talk about it. So the slogan here, let's somehow build chatbots you can actually chat and not just talk about it. Chat with it and not talk about it. And there's some more general questions I'm going to raise. Then about this open source part. How OpenNLP and mostly OpenNLP and Stanford NLP, what kind of tools and how it can help. And then we go through search engineering, some interesting search engineering tricks, what you need to do to proceed from a search engine to a chatbot, how you need content management. Again, you cannot just throw a lot of examples to chatbot. You need to manage this content. And then dialogue management, 3 topics using different types of discourse analysis, what is called here rhetoric agreement, how you can build dialogue from initial query, and more specific advanced topic, how chatbots deal with argumentation. So what are the issues? Again, a lot of buzz. If you go search for like chatbot demos, very hard to find. And the comparison I'm trying to make here. This is like aviation in 1900. So although there's so many companies doing chatbots, although like so many conferences and all people keep talking, everybody's talking about chatbot, there's still not much you can play. Compare with search engines in 1998. In 1998, not everybody was speaking about search engines, but you can actually go and try and get some information. Today, like, you call Bank of America, you spend 40 minutes on a line, or you call IRS, still a lot of need for chatbot. But you cannot, I mean, still most people, like, so if you have your favorite chatbot, and which really helps you in everyday task-oriented problem, I'm not talking about like Alexa, like entertaining, I'm talking about serious problem. Yeah, let me know, and I'll update this presentation and my thoughts. So what I did, I went to web, just go to Google, search for chatbot demo, deep learning chatbot demo, whatever chatbot demo, and most of them just even very hard to figure out what they actually know, what kind of questions they answer. And here I used all broad spectrum from small companies, university chatbots to IBM chatbots. It's still hard to see the usability. So this is my analysis for hundreds of Google search results, online chatbot demo. So 5%, at least you can understand something is happening. 5% very basic questions, name, color. They can ask and answer back. 15% deep learning, it's just totally random. Hard to see, possibly entertaining for some people, but hard to see how they help you accomplish a task. 20% just a movie, and 55% not even a movie, just talking and talking about chatbots. Those available chatbot, no conversation. Again, very simple. And I mean, these days, web search engines, a lot of web search engines are pretty good. But compared to chatbots, still at least somehow build it around the search engine. And most vendors, this is another approach of platforms. And for platforms, you don't know who's responsible. Like Google, Facebook, Amazon, and ourselves, we provide platform. Then a developer, like a bank or like a hospital, is supposed to build a chatbot. And then who is responsible when it's not working? And that's mostly the case. And again, very hard to find. Go try to find like IBM, Facebook, Amazon, very hard to find. This is how.
That you don't realize are chatbots.
Well, I think as a user, as I said, we want it. Okay, call typical larger bank, spend 40 minutes just expecting, and all these 40 minutes you would be dreaming about a chatbot. Yeah. Like you have somehow your credit card is transactions declined, spend an hour on a phone waiting, and then yeah, you do need a chat. That's a basic problem. For that, chatbot is not as difficult. So this is Amazon review for Amazon chatbot, and as you see, basically people don't even know. People try to figure out what to expect. These random answers, probably deep learning based. There's no random, and so what do I do with it? People aren't sure. There's much more negative reviews than positives. So what can we do about it? At least divide into components, and they try to treat each component. At least they need to differentiate between the user asking, like please do something, and asking a question. And this, you don't need sophisticated machine learning. You can even start building like simple linguistic templates. Machine learning would help. But it's example, a lot of problems you can solve in a simple way, but you need proper architecture just to divide chatbot into components, figure out which components you need, and then try to solve one by one. For example, how a platform of Google Dialogflow, Facebook, Microsoft approach this problem? They just consider everything, they call it user intent. And they reduce everything to user intent. Ask questions, search engineering is user intent, do this is user intent, differentiation between asking, that's why it's so unreliable and easily confused. And if you confuse this simple thing, your conversation is lost. If I'm first asking how to open account, and then asking actually now do open account, and if the system confuses, you're lost. You don't know what to do next. Then relevance. Again, for search engine, because many people ask the same thing all over again, you can learn just from whatever answers people choose. Cannot do it for chatbot, so you need syntactic analysis. You need to parse query, you need to parse answers offline, and then you need to linguistically compare. Again, if it's like shorter query, and especially for longer query, you cannot just rely on like TF-IDF as default relevance. You cannot just define frequency. You have to, I'm not saying fully understand, but at least treat user question with some linguistic respect. Dialogue management, that's the hardest part. But there's some tricks, at least you can do simple stuff. For example, do co-reference. If you have first utterance and then other utterance by user, try to see if you have a pronoun in the second and try to associate it. And for that, Stanford NLP will do it pretty well. Just that will impress your user that at least you understand that the second utterance, you can merge constraints from the first and second. And we look at examples. Clarification requests, very powerful. If you have multiple answers, such as search engine just gives you multiple answers. If you have chatbot, do clarification. Do you mean this or do you mean that? So I suggest, since we covered like problems and what you need to do, let's look at the demo. And meanwhile, can you come up with a question like financial, whatever, like serious question? So I'll going to show a little bit how clarification works. Like, what would you like to know today about like banking accounts using credit card, or like legal, maybe health question? I just wanted to be real, so I wanted to be your question. Okay.
I want to schedule a haircut appointment.
No, it's not about. It's about knowledge question, not about request. It's just different mode. So what do you want to know?
So I want you to compare your versus Google's demonstrator, because we said Google not demonstrators.
This is knowledge. You ask questions about knowledge, not because when you have a tasks are always limited, and I'm talking like any knowledge, history,
What is
architecture.
good,
Okay.
Home buying insurance rate for a 30-year mortgage. Or I should say not insurance, mortgage rate. My bad.
Grade 4. Good.
What is the home buying mortgage rate for 30-year mortgage? Get rid of the insurance.
Oh, okay, like this. So it goes to different sites and tries to find information. Then it parses the data, tries to extract topics. And now what it's going to do, it's going to suggest topics. And then from these topics, and the topics are usually as a short phrase. And this is done linguistically, not statistically. And then you figure out. So let me read a few options. Like you have different types of PMI. Can I avoid paying mortgage insurance? Pay PMI premium? Who is required? How long do I need to? Then instead of reading through answers, you're reading through these topics. You select topic, and then you, like affordability score for each metro. Let's do. So the system issued clarification request. It tries. There are many different issues associated with our question with home buying insurance. And let's say we are interested in what they say metro areas.
Would you increase the font?
Yeah, the font is very small to read.
I think I cannot increase for this terminal. So you get a brief answer. I can make it.
Just try Control Plus.
I can do Control Plus here, but not. So this is a website based on your topic, and this is a brief text. So what I showed you, system has rather rich knowledge. It can get multiple websites, try to generalize and extract topics, then give you topics to choose, and then really narrow you down at particular answer. Okay? So now maybe questions about this and about my critic, and then we move on.
When you
Yes.
say it has rich knowledge, do you mean that it just has a collection of documents and sort of knows what they're about, or is this sort of search-based, or does it have
Okay.
like a knowledge?
So because it's a broad domain, it is I cannot do ontology, so it is without ontology, but all linguistic means are available. So I can parse, I can extract from web page. I know what are the noun phrases. I know how to convert noun phrases in one form to another in equivalent form. So I see if there are multiple noun phrases, named entities, or just non-named entities, noun phrases in different search result. Then I can combine them, and then I give it to, yes, please.
So you realize that you go to Business Insider, and how do you rank your reliability and robustness of the source?
Okay, just knowledge from the web. Actually, I don't know what is about Business Insider. Okay, just knowledge from the web.
API to do your submit a search?
Yeah, I mean, I'm using Bing API, yeah. So I'm going to different webs, getting data. So, okay, for example, if I do it for a bank, then I can have the same thing, but for internal source. Or I can Blender. I'm just showing the concept of clarification. So you have broad questions, then you have options, then you narrow down on particular. And then it's up to the developer, right, to point me to particular source. Okay, so more questions. Yes.
Yeah, to relate to the previous question, if you know a particular domain is finance, can you focus your web query search to reputable finance places like Financial Times or something like that?
Okay, so that's not really, so I'm showing the concept, and if I do it for particular bank, they will take care of.
Okay.
So there's also access control and all kind of, they're going to be sorted by whatever popularity, but whatever by advertisement, but whatever given content provider will tell you. So that's not really relevant to chatbot. Okay.
In this drilling down process, is there some notion of like subsumption, or this is more general than that, or
Repeat the questions too.
Notion of subsumption in a sense.
this is more general than that?
Okay, so at least it is not done. So no, like we extract topics, and how do we compare if topics one topic is subtopic of another topic? So what is done here, because the domain is broad, so at least noun phrase is normalized. So we can have rates for mortgage account, or like 30-year rates for mortgage account. And for that case, the system will know that one is subtopic for another, because it's subphrase. If you formulated totally different words, like interest rates or like percentages, then in this domain it will not figure out, because in this demo there's no ontology. For specific domain, for example, again, if it's only finance, then we add ontology, and then we can figure out that different noun phrases can merge into the same topic. Okay. So again, I mentioned coreference, which would help for consecutive query. For example, you could have asked, so what are there, like in this area, but then you can ask additional question. Again, something you cannot do using search engine. So what is useful? Automatically learn relationship between entities. For example, learning from Wikipedia. So if you have a new question, something like new entity, okay, this is ABC123, you don't know what it is. If you go to the web and search for it, and if you find Wikipedia page, you will see that ABC123 is something. And then you can figure out this relation and figure out relationship between entities. Okay, I repeat, how not to build chatbots. Throw tons of dialog data at machine learning system and believe that it will figure out above items automatically. Although it's a very, very popular approach these days. Okay, and also welcome questions and disagreements about this topic. So what is my motivation? How I try to explain this? So we have images, we have speech, we have machine translation, but chatbot, we're dealing with linguistic structures interpreted by humans. So once you convert linguistic structure into numbers, like numerical feature space, you cannot interpret it anymore. And even if you're doing that, you can improve some algorithm performance to a degree. There's no way you can fix it or improve particular cases or you integrate. Because once you convert linguistic structures, which humans understand, to numbers, you cannot do it. You cannot do anything. Okay? Again, I accept counterclaims and disagreements, but just for images, if you look at these pixels, I mean, these pixels don't have meanings, they just have values, right? So you just throw a lot of images, machine learning, fine. But if you have text, text have meanings. And once you throw it to a neural network, meaning is lost, it's only numbers, okay? And again, you don't, so if you disagree with that, and still deep learning enthusiast, I'm talking about discourse structures. You can do deep learning of discourse structures, and people do that. So it's still, you don't have to agree with me on that, but nevertheless. Another claim, do not do, you have a chatbot. It has to complete certain tasks, like advise you on interest rate, what kind of mortgage. So where is randomness? You have a person, and this person needs to know for sure what's the best recommendation, what's a logical recommendation. Like my credit card gets declined, I call to the bank, where's randomness? I either want to say, like, we disapprove you, like forget it, or we're going to recover it for you. Where is randomness? That's why I'm saying dialogue management based on probabilities for task-oriented to guide design probably not going to work. Because then who is responsible? It's not doing properly. Who's responsible? How can you tune it? You're going to tune probabilities. That's another. And again, if it's very simple application, garage, I'm not sure, you can do probabilistic. Sometimes it's working, sometimes it's broken. But if you really do task-oriented dialogue, then yes.
Can't these be combined in useful ways so the system might think, you know,
okay.
Think with a 90% probability that he's wanting a new credit card or something, and then it could ask him and verify that, and then proceed down the more deterministic.
That's actually, okay, so the question is, if system believes that with 90% probability you want a new card and 10% probability you want to update, like you want to reactivate your existing card. And I would answer, okay, just handle those probabilities as equal and consider both cases because you don't want to make errors. Okay, you don't want this chance to happen. So where we get probabilities? When we get noisy data and then the data does not support the problem, then if we have a lot of dialogues from our training set, and obviously it's represented not exactly what we want, then we have different frequencies, which we in machine learning model reflect as probabilities. We do it not because we should use probabilities, because we don't have any other option, because that is the data we got. That's why in this approach, less rely on data, at least less rely on noisy data, but instead go deep and do whatever you can get in addition from linguistic analysis. But because it's deterministic, you can use fewer amount of conversation log. And then the focus of this project is on difficult topics. So for this project, we did analysis of customer complaints during the time of financial crisis, 2007. A lot of people complained about that banks were reshuffling transactions to charge more non-sufficient fund fee, and also they raised interest rate. So we were processing these complaints, and we're trying, how do people express their problems? It's usually a few paragraphs of text. They explain their position, explain position of the bank. So there's enough data, and because the topic is the same, there's enough data to figure out how people try to convince that they are right and banks are wrong. And in this case, at least one side is cheating, right? One side is deceiving. It's either bank deceiving customers, or customers misrepresent what actually happened. So this way we can see what are discourse structures of lie and what are discourse structure of normal, like factual test. And that is other application is detecting fake news. So once we figure out what are the logical flaws, how people organize their thoughts when there's a serious problem and they try to prove us that the opponent is wrong and they're right. So we learn from complaints and we rely on these structures of building the chatbot. And again, in these serious problems, even customer support agents are having problems explaining. So a lot of people, they have problems on the one hand, but also I suspect there's some shady bank practices. So even if there are simple way to explain, probably they avoided that. Nevertheless, it's a very interesting text to learn how people logically express their argumentation and their thoughts, because I mean, it is important for people. People were like losing houses and losing money on their accounts. So that was a serious problem. Now we switch to this open source component. Very briefly, there is very popular these days Stanford NLP and OpenNLP. OpenNLP is Apache project, so it's like unlimited, free. Stanford NLP has some limits. And this project, the objective of this project is to make it easy for non-linguists to just use it without really learning linguistic concepts and getting into tuning. So it's a wrapper. You don't have to know how models work, why you need parsing, what parsing does, how parsing is associated with named entities. You try to build your engineering system, you see what kind of relevance you expect and what you get. And then you experiment with your problem. And again, you don't really need to go deep into linguistics. And there are multiple applications available from this open source project. And the central part is similarity on parse trees. So the default measure of similarity, you just measure how many common keywords between question and answer, and then different keywords have different weight, different importance. And this importance is a very random, it's a very tricky thing. So what we do here instead, we parse each tree. So we have part of speech. We have labels also for relation between words. And here you can see maximal common subtree, which in this case just one common subtree. So the simple observation, the larger the size of the subtree, the higher the relevance. And then it is important what part of speech, and it helps a lot when you have more queries, more complex than 2-3 keywords. Because then there is certain linguistic structure, especially for product search, for recommendation. It is important to understand what are the phrase structure.
What is your question? What is your distance metric? I mean, obviously not a unit.
Okay, distance metric. So if you have keywords with weights, your distance metric is a number. In this case, distance metric is a common like substructure, which is subgraph, which is interpretable by human, unlike number, right? If you ask about apples and you got banana result, and then default Lucene model gives you relevance 0.7, what does it mean? How can you interpret 0.7? And in this case, you have subgraph, which you can read and make sense. Some subgraph, you can have the same part of, maybe the same word, or you can have a different word, but the same part of speech. So at least when as a human you read, you look at overlaps between these trees, you can interpret it, which means your machine learning is interpretable. You understand what kind of rules the system can learn. And again, but the distance, you can still do a number. In this case, how many common nodes in this, you just count the nodes. And this is a simple numeric measure. You can still get a numeric measure if you want. But again, before you have a numeric measure, you have a linguistic structural measure you can interpret and make sense, unlike numbers, okay?
Do you do anything scaling TDF, IDF style for the,
Okay.
if you have two sentences that are super long versus
Okay.
two that are super short?
So usually this type of model works on top. You have like geolocation, you have popularity, you have all kind of scores, including TF-IDF. And usually this model is optimized to have a weighted sum, like default relevance model plus linguistic model. So for example, it's like you look for event, it's mostly about location. Doesn't matter that relevant event is 1,000 miles apart. But this gives you a systematic way how you can tune and machine learn relevance, linguistic part, okay? Because again, words, for humans, words are interpretable and numbers are not always. And then there's a chatbot. This is 2-year-old now. And on this GitHub page is a brief instructions how to install it and how to run it. And maybe more detail, we zoom in, more specific, I'm going to enumerate. It's different components from Stanford NLP and OpenNLP. Then this verb net, system needs to know English verbs. Then coreference. And then what we call here parse ticket is generalization of parse tree for individual sentences. When you have multiple sentences, like in chatbot, user can describe their problem in a paragraph of text. Then it's a representation for paragraph of text. In addition to syntactic information, it has all these verbs and also how sentences are logically linked. So just briefly. And then it's also integrated with popular word-to-vec and different learning algorithm. Like mentioned here, nearest neighbor learning, just similarity, what I showed. If you have like 10 answers and one question, you just measure similarity between question and answer using this parse tree. So this is the simplest nearest neighbor learning. Or you can apply more complicated, like scikit-kernel learning. It's a separate, but you do specific support vector machine, not in a vector space, but in a space of subtrees. Again, we are learning linguistic structures and not numbers. So instead of learning in numerical space, we're learning in a space of subtrees of parse trees. And that is a separate, yes?
How do you know that the metrics that you're developing here are good?
Okay. There is, for example, you can compare it with the search engine. What you can do, how you can adjust metric. For example, how do you know which weight for nouns and which weight for verbs? You run 1 million queries from, for example, Yahoo Answers. Then you have your own sorting, your own ordering based on this algorithm. And then you have Google ordering or Bing ordering. And then you modify weight so that your ordering fits Bing ordering as much as possible. Yeah, so that's kind of traditional what you can. But after that, you can still improve other features. So you can then take Google results or Bing results and then reorder them linguistically for improvement of relevance. But still comparison with search engine, with web search engine will help you figure out. Okay.
Well, let me continue. Yeah. How do you optimize? As I said, what's
okay, it's a typical how to optimize.
What's good here and what's bad?
Okay, so for example, when you, it's compartmental model, you have a component. Given component, you define good is, make it as close to Google as possible, for example, this component. You may disagree, but at least that is what available. Or you can just do Yahoo Answers. You can just have this exact answer without using search engine. You can just have question-answer pairs. You can have Yahoo question. It can be Yahoo answer to this question, or similar keywords, but Yahoo answer to different question. And then if your system give a different answer, you penalize. And if not, you give it reward. That's a pretty much training set-based approach. Okay? Okay?
So we were talking about looking at the similarity between questions and answers. But,
Yeah.
And that, I think that kind of assumes that the answer is going to have a lot of overlap with the question or something. But something more like typical intent recognition is you're sort of looking at similarity between questions that all map, that all have the same answer or something like that. So you're kind of learning the.
Okay, you have, actually, that's a topic we're going to cover. We have many questions for one answer and how to generate them, how to, if you have an answer, how to automatically build sample questions for this answer and how to match. That's what we're going to cover. now let's go, now it's time for discourse analysis. So this structure is a discourse tree, and this is simple case. So typical search engineering, how Solr, Elasticsearch, how default search engine is working. You have documents, and you index everything in these documents. Maybe you give higher weight to titles, but still search relevance keeps improving by whatever means, and this paradigm stays. Whatever content you have, just index it. And using discourse analysis, it turns out we can do much better. We can at least understand how the text is organized and figure out what to index and what not. Like I give you, like imagine we have an answer, we have a content. This camera shoots well in low light, so I made a few good shots on a boat at night. So if you are search engineers, will you index the whole thing, or which part would you index? Exactly, top part. Let me give you a better example. Like, this camera shoots well in low light, then I took it to my friends, and I took it to a party. Who cares what I did with this, right? It's a review. Who cares what I did? Like, this is important. This is the fact. And then this is somehow my secondary importance thing. Who gave it to me? Who said something about it? Whom I'm referring to provided me this information. This is secondary. And this can be misleading. For example, if I ask about night boat, this shouldn't fire as an answer. So keywords are perfectly good, right? So what is the trick here? How do you know which keywords to index and which keywords not to index? Keywords are maybe frequency-based. These are totally appropriate keywords. But because we know the logical organization of text, we take this text, we build this discourse tree, which what it does, it splits into two parts and saying what is main, called nucleus, and what is satellite, what is important, what is less important. And they're connected by relation. Once you know that, for any text, I know what to index and what not to index. Okay, so it's a good time for questions because that is not done in search engineering. So that's why I want to focus, make sure it is clear. See, another way to think, yeah, yes.
Based on the question, you're taking out a certain part of the document.
Yes.
And you're getting more relevance in terms within that.
Okay. So the way to express what I do, you split document into parts and then take more relevant. I would say it's almost like that, but I'll try to define it more precisely. So the relevance is usually relative to the question. And this is absolute relevance because, okay, another way to look at it. We have a news article, like facts, and then we have discussion thread. In discussion thread, people tell all kinds of stuff. They like against each other, it's some swear, whatever words. But for a web page, will tell us which part we should index, right, and which part we should not. In regular text, it's kind of like that. It is important. This is informative. Camera shoots well in light. This is informative. And what I do with camera, that's my business and not the search engine business. So it's not relevant to anything, according to this model, okay?
So if somebody says, I want a camera that works well at night.
Okay.
It seems like it's a
It will
complicated
trigger.
inference. It is there. It seems like it's a complicated inference
Okay.
to figure out.
Okay, so this way to avoid it, hopefully there will be another camera at night. If there's no other, then you have like your fallback index and then still give it. But you only do it if you don't if you didn't find the match with good part of index.
I mean, would you advocate doing the inference? And
Okay,
saying
okay.
light means no light, or
Inference is a nice thing, but it's domain dependent. And discourse analysis is domain independent. It figures that this is explanation just because of so. So once you want to make inference, the whole system becomes much more complicated, and you need to build ontology. System needs to know what are camera and what are nights.
So are you triggering on discourse markers like so, however,
Yeah.
things like that?
It's not that simple, but just see. The indicators of discourse markers sometimes they're not always simple, but at least you don't need to know the concepts. Okay, you just need, you just have the structure.
Or what are your
Okay.
triggers to separate the discourse, the secondary from the primary?
This is something more important, something less important. Okay, so we can do, now there's a complicated, now there's a real example. This is example from question answering, like FAQ data from some financial web page. So what are it, so the idea, so far we saw just two parts. And it turns out that discourse representation we can organize as a tree. The leaves are text, the labels for leaves are text, and then you can have two parts. This text on the top and text on the bottom, and they are connected with elaboration. Elaboration is a default relation, it means just give me more details. But usually what's on the top is important, and what's the bottom is least important. So here, I build the whole tree, and then for each relation there is more important part, informative part, uninformative part. There are exceptions, and you can handle it by learning. But the simple way to look at it, you don't index what we call satellites, uninformative parts, and you only index informative parts. Let's look at examples. So nucleus means important parts. Like those should be matched with user queries, and these could be misleading. Like good idea. You don't want stuff like good idea to match with anything, because good idea is broad, right? Tax cost. So most of these are specific. So these parts only meaningful in the context of satellite. So less informative part are only meaningful in the context of most informative. So if they happen, if these parts match the question, then there's a problem. So you try to avoid it. Okay?
Question?
Yes.
So you also write books, understanding how things, some phrases are more important and less important. Does that impact any of your writing style? Like alternate more important, less important, or try and stick to a higher percentage of more important, or?
Okay. You don't have control over it. This is how you organize. There's always half is more, okay, think of, in terms of volume of text, half is always more important, half is less important.
It's just relative.
It's all relative.
Totally relative.
But whatever is in satellite part, it's always, it doesn't matter what kind of question, what kind of reader for what I'm writing, it's always less imputative. So that's only interpretable. It only makes sense if this nucleus part is used. Okay?
I think I missed something. What was the
Okay.
EDU?
Okay, what is EDU? EDU called elementary discourse unit. So this each part is EDU. How you take text like this. First you split it into two parts. Like for example, usually by sentence. Then you iteratively split that into two parts. And large chunks you cannot really assess in terms of importance. But once you go to the level of individual like phrases, parts of sentences, then you can tell. If it's conditioned, like if you under, then do this. In condition, like if part is less important than what you're actually doing. Like for example, you have a question like how to use funds from your retirement account. Then it's a good answer. This whole thing is a good answer. But if you have a question like I'm under 59, yes, if you're under 59, that's applicable. But that would be not going to be a good answer, right? Because this is a condition. You don't match your query with the condition. And again, to repeat, no search engine does it. So today, the problem of search relevance is fixed by, well, say indirect, by some other means. But this means nobody is doing. And for Chatbot, it is important. So once from text you know what to index, what is not, once you index wrong parts you shouldn't have indexed, it's a lot of, then your precision goes down. Because obviously there's a lot of keywords that trigger that part. And if you have a default, you cannot fix it by keywords. Because the same keywords can be in both parts, right? You cannot fix it by keywords. So modern search technology cannot handle this unless you do discourse parsing.
Is there domain-dependent stuff
totally domain independent, right? It's just so if. It's discourse parsers today are only for English. For other languages, much harder. But it's totally domain independent. So you do it just once, and then it works for any domain. Okay.
Even very formal domains like medical, legal.
Yeah, as long as it's English grammar. So as long as parser can parse it and figure out discourse parsers like if, and then end of if, and then different phrases, it is working. So if it's grammatically correct, then it's all applicable. Yes?
Is this parser trained on some data set, or is it like manually?
Okay, okay. So it's a long history of discourse parser. So how do you build discourse parser? How you train them? It is a manually tech data set, because what people did, they manually built. It's only 10,000 discourse trees. That is why they manually built it for news corpus. So for news, it works better. For engineering, for technical text, for legal and medical, not as good, but still reasonably, because usually syntactic phrases are similar. But that's a big limit, and you cannot automatically learn, unfortunately. So it's a totally, you have to build a training set, you have to build a lot of discourse trees, you have to manually tag what are the relations, and a lot of like human years are spent, and still the training set is very limited. That's why accuracy is way, way lower than accuracy of syntactic parsers, which are very reliable these days. And the discourse parsers, they only appeared like 2 years ago, just recently. Okay?
What's the accuracy percentage?
70%. That means, so default, it's like think of, you have a syntactic parser and everything is noun, unless you have evidence, unless it's a verb or pronoun. In this case, if system is unable to figure out relation, then it's just elaboration. And it's 70% accurate. It means that if it's unable to figure out something like specific condition or enablement, then it's just elaboration. But the structure stays, and structure is also important. So whatever we do with chatbots can tolerate errors in discourse parsing. Okay.
So the way you can do transfer learning from an ImageNet model to other image models, is there discourse models that can be leveraged for starting a new discourse project?
I think how can you build?
I mean, if you're triggering on the if kind of conditions and the end of condition, that kind of parsing, that's domain independent.
Oh, but if not always condition can be many different cases, so not as simple. And again, you cannot. There's still only manual work to build discourse annotation. That's why learning is so limited. Like machine learning approaches, all kind of approaches were tried, and that's not a bottleneck. The bottleneck is the training set is very limited, and it requires manual work to build. For the management system, I just want to mention it's more like architectural part, that you have a content pipeline. And again, this is a counter argument versus pure machine learning approach, when you just get a lot of customer support logs. People also use for training like movie scripts, movie conversation, just a lot of all kinds of conversation, just throw it to machine learning system, and then you hope that it will find in real, like somehow learn from it and support the conversation. So I'm saying instead, you have to deal with the content. I just wanted to show like high-level picture. You have to collect data, you have to deduplicate this. Still, you have to work with content for chatbot as you do for other applications. And usually, customer support data is very noisy. It's a lot of utterances, a lot of repetitions, people disagree, people complain. So it's noisier than anything else. And you cannot just learn from it without any. Another disadvantage, in my opinion, of a pure machine learning approach, you have syntactic relevance. You have also dialogue management. And when you just learn from data, you mix all kinds of learning. It's like we send our children to school. One approach should be, okay, why do we need to study chemistry, math, all this? Why do we need to structure what children learn? Let's just throw like 20 books at them and let them figure out. And some actually will figure out, but most students will not. So this is my comparison for pure data-driven approaches. You have to organize data for learning, not just like throw whatever. Let's look at this example. Now it's a very different topic, rhetoric agreement. So you have a question about entity. What does this entity do? And then some controversial question. What does this entity really do? Okay? And in default search engine, really it's a stop word. So there's no difference. But we know, like, from this example, there's a big difference. And you cannot figure out that just by relevant. Topic is the same. Like, this is an entity, tell me about this entity. Okay? But we have totally different answer. First is official answer. This is an entity, this is entity definition. And the second answer is we expect the entity to do one kind of things, but it turns out the source of the internet that this entity is doing something totally the opposite. So how do we figure out? And for chatbot, it is important. Chatbot, we have user disagreement. We have some, especially like banking. If there is a conversation went far, it means that there is a disagreement. So client wants one thing, and banks most likely wants different thing. So you have to communicate properly. You have to understand this difference. And again, this is not about topic. It's about how you organize your thoughts about answer, right? Because again, entity is the same. So let's look at discourse trees. I use different software to visualize them, but just want to have a broader look how they're organized. So we have also the same elaboration mostly. Joint means symmetric, the same thing, just combination. And so when you say, what did you really do today? Like if I ask you, what did you really do today? The default answer will be, I just went at work, like worked on computer. But if I ask you, what did you really do today? Then maybe I expect something different, okay? And you can see it by the discourse tree. If there's a contrast, if I asked about entity and there is a contrast, you cannot just give definition of an entity. Like for a human conversation, if I ask, what did you really do today? Maybe just didn't go to work, like slept the whole day. So by the way I organize discourse of my question, the answer is very different. And no way you can figure that out by relevance means. Okay, this is not about relevance. This is what I call here rhetorical agreement. Okay, so discourse trees for the questions are different. That's why the answers also should be different. And there's a certain what we explored here. What are the correlation? If you have a longer text, if you have some certain logic flow in your text, in your question, then the answer should reflect it. Don't just give me pure fact. If I took time to express certain reasoning, if question I have certain expectations, you have to handle them. And this is done in addition to relevance. So you find relevant answers, and then you find answers with rhetoric agreement. This is some complicated situation about like paying insurance for the truck, which not naturally owned. So what we do, we build discourse tree for the question. This is clarification. System asks, like, did you mean what are the options? Users select the options about insurance. But now you cannot just give insurance from a definition, right? Search engine would do that. Search engine would just give general definition. But in your answer, you have to reflect what has been asked, not just the topic, right? So when people get upset, like with chatbots, even with human customer support agent, you describe your story, and they give you just general rule. Okay, usually it's not helpful. I'm still upset. They want to explain to me that my particular situation, because of this and that, should be handled. And it can be systematically done using discourse trees. So these are more complex discourse trees. Again, the same organization. It's a tree, and the leaf level elementary discourse units or portions of text. And what you see here, once relevance is established, so let's say we have this utterance, we extracted phrases, we found 100 equally relevant answers, but now we rank them not by relevance, but now by rhetorical agreement. What is the better way? We have two relationships of contrast. So what was the problem there? That I don't own my truck. Why should I pay insurance? So you cannot just say you own whatever property you have, you should pay insurance. It should be insured. Because it doesn't reflect the logic. So if you have contrast in your question, then it should be reflected in your answer. Okay, again, web search engines don't do that. Okay? But chatbots should, right? And for answer this question, to handle this situation, I don't own it, but I still have to pay insurance. Okay.
Are you generating parts of the answer, or are you always
In this case, it's like a search engine. I don't generate, I have answers, the same default search engine, but in addition to topical relevance, like what everybody does, here discourse level relevance, discourse level agreement is done on the top. So the same search engine, but you have additional component which further reduces acceptable answers.
So a short question will get general answer. A long, complex question with a lot of discourse
Yeah.
will get a long, complex
Exactly.
discourse answer.
Yeah.
That
And
kind of
again,
matches the level of
you
detail.
cannot answer these questions like just this part, for example. If you have, like, do I have to pay insurance on something? Do I need to, something I own needs to have? Does it have to be insured? Then for brief question, brief answer is good. Or maybe brief answer but without contrast. Just brief answer with details, with elaboration. However, if person is saying, this is what I have, this is my problem, I expect one thing, but they want me other thing, there is a contradiction. So you have to address this contradiction in your answer. And even human customer support, if it's not done properly, then there's a problem, right? A user is not satisfied. User gets a decision, but user is not happy because, okay, I explained my problem, but my problem was ignored. This is another example. Oh, by the way, some of these examples do not comply with requirements of Apache Conv. They have certain requirements for the topics. And I'm a little bit broader on the topics than typical presentation, but because it's a linguistic thing. This is one more way to express a little bit different way and explain how you express discourse. This is based on Stanford NLP. Everything in black, parsing, and black edges are syntactic relations and parts of speech. And everything in the red, discourse relations. So you have elaboration, contrast, join. So again, this is a controversial question. There's no simple answer. So to satisfy the asking person, that is a real question from Yahoo Answers. That's a real. What I'm showing, you have to somehow maintain the style. You have to maintain the style. So for this case, you cannot really satisfy all the constraints formally for the question, but you have to maintain the style. So on the top, there is a discourse representation for the question, and this is the discourse representation for the answer. And the arcs between showing that the discourse relations are coordinated. Again, if you have contrast in question, like I had a baby, it doesn't look like me, what should I do? I mean, it should look like me, but it's not. So there is a contrast. So you cannot, if it's you're a marital therapist, you cannot just say, do this, do that. You have to reflect this contrast, okay? Okay, questions? I specifically showed a different representation. For example, if you work with Stanford NLP, this part you will get by default from Stanford visualization. And the red part you get from discourse parsers and from the components. I have it on GitHub page. Yes?
Do you have evaluation results that show that this gives answers that are more satisfying to people and are more correct?
Again, so we have Yahoo Answers. And what is one of the experiment you do, Yahoo Answers is a huge set. So for each question like this, there are many answers, including keywords like baby, mother, husband, whatever. And if using this approach, and Yahoo Answers are written by humans, so most of them make sense. I mean, makes more sense than usually than this kind of type of question. So if I run search, then I apply this evaluation, and then I get closer to what humans assign, then system performing better. If I get random answer, the same keywords but not what actual question-answer pair from Yahoo Answers, then my rhetoric agreement is not working well. So again, this is a machine learning problem. I just adjust the model till it performs as close to real Yahoo question-answer links as possible. Then one more addition, you have traditional discourse trees, and one of the addition to this project, you add communicative action. Communicative action is speech acts is how people, when there is a dialogue, which communicative actions people use to communicate the dialogue. So this is information complementary to discourse analysis. So this is an interesting story, developing story in parallel to development of this technology. It started in 2014. Theranos is a blood, some of you may know, blood company. And initially, I was taking content from their website and their arguments against Wall Street Journal. And I did rhetorical analysis. And as the story developed, we improved the learning and developed it better. So basically, it helps and figure out what kind of argumentation, and based on discourse trees and what kind of communicative actions they used, you can figure out where is the truth, who is lying and who is not. Again, you do it by machine learning. You have a training set with complaints when at least some party is lying, right? Then you have a text when nobody's lying, just, for example, news articles. Well, they factual lie, but not logical lie. And then you can train and you can figure out if it's similar to a part of training set which is lying, then, so again, machine learning approach. This another, now, how can you figure out, it's the next topic for the discourse analysis. If this is a, how to build your dialogue from the first utterance. So first, customer explaining a problem, and then you need to handle it somehow. And in a lot of cases, if you give a chance to a customer to explain a problem with sufficient detail, sufficiently, then you can already figure out how to handle, how to organize your dialogue further. So you don't have to really learn each utterance. What you do, you capture the initial logic, and you know, okay, there are like two contradictions. Let me handle them step by step. So the answers are artificial, but it shows, I'm going to show the concept. So this is one more way to visualize discourse trees. This is the top, and see. So we look at this discourse tree. This is initial utterance. And we see, okay, so there is a temporal and contrast. So let's try to first respond to that part, then maybe it helps, and then respond to that part. So we separately look for the answer for this part, and then answer for that part. And coming back, what we did, we built a discourse tree for this part. We split it into two pieces. First, recommendations like being online, and second recommendation like anonymized and whatever. Again, search engineering. You take phrases, you find candidate search results, but then you filter them by rhetoric agreement. So discourse trees need to be coordinated. So on the top, it's just elaboration. And this is enablement. So do this to achieve that. That is specific rhetorical relation which tells you like a kind of problem-solving rhetorical relation. Like do this to achieve that. Yes?
9-minute warning.
1 minute. Okay. So I think we close to the end. The result is what I mentioned, like how this idea is working. Okay, let's have a doctor visit. There is a research showing that we're going to skip that part. This research showing that if you go to doctor, you're only allowed to talk for 11 seconds on average. And then the doctor interrupts you, and doctor already builds the model of a dialogue with you. Okay? So train doctor, it takes 11 seconds. So basically, this is a proof that at least humans let a customer complain for whatever, express whatever for 11 seconds, and then it's already, for the doctor, the further dialogue is clear, further dialogue is built. And again, that is how we build Chatbot. I'm going to quickly run through the algorithm, formulate a problem, explain these are the items, try to split the problem into parts. For each part, produce clarification, request clarification, let the user clarify it, and then make another step and give answers. And again, this is kind of hard-coded, but this is general. Machine learning approach, like pure machine learning approach, data-driven approach, would be like saying, we don't want to like give names to different interaction modes. Just learn from human interaction. Maybe you need 1,000 different modes. And this approach is saying, maybe you need just a few. Like get as detailed initial information as possible, figure out steps, split into parts, do clarification, as I showed you, do clarification requests. But this is still not a hard-coded dialog flow, right? Because first you can repeat this routine. You can have 2 parts, or you can have 5 parts, 5 steps. So it's still general enough. But you don't have to reinvent or like rediscover 1,000 different dialog modes. And I think I'll skip this one more example. Turns out that car repair turned out to be more formalized data set, also used for training because there's a lot of repair and the number of types of problems is limited and data set is huge. So also coordination of discourse trees. And then, again, using this approach, we try to optimize. We use different features and we try to see if we can, using this approach, we can construct real dialogues from just separate utterances. So if we understand the discourse, right, we can build real dialogues from the options. If we don't, then it's random. Then we just do it by keywords. So how close we are to the actual, then it means our discourse part is working. Let me maybe skip argumentation, I think because of time. That's a very specific topic, okay? I'll skip. Maybe do more questions. And let me skip to conclusion. So it's about efficient access to information. It's not, this approach mostly not for entertaining bots, but task-oriented bots. It's okay to have problems. We see problematic sessions. We build discourse trees. We accumulate proper discourse tree pairs from user utterances, and then we improve. And then one comparison I want to make here. The chatbots build pretty much rule-based deterministic chatbots. They are in a lot of sense like autistic children. So autistic children have some interest. And if chatbot, if we are in the domain of chatbot, it will tell us. If we're talking about banking, it will tell us about banking. If it's not, it's probably, and it should just refuse. And if we learn from huge amount of data and we don't have a strict vertical boundaries of what we answer, then I call it schizophrenic behavior. So deep learning bots, it's mostly, I think, should be diagnosed modern and I think future with schizophrenic. So they just want to talk about anything without stop. And this is how they optimized. They optimize in a way, let's just as long conversation as possible. Like, what is your name? And here's my name. I love this, you like that. So we need to, again, we need to differentiate. The bots we are designing, we're not going to do as smart as human, but at least let's try, target autistic children and not schizophrenic. Okay, so that's.
Is there any kind of mental disorder that the bots that you are experimenting with?
Oh, so I'm doing those. I'm doing autistic. I mean, kind of intentionally. So they only answer what they know. Specifically, obviously, they're not smart to answer about other stuff. So I'm building a domain model. I'm building discourse. And they do certain things well. But they're not random. because the behavior of schizophrenic individuals pretty much, they start conversation and they cannot stop. We don't want that for task-oriented bots. Just do less, but do it in a meaningful way. So this is a slogan.
So ideally, you'd have something that sort of knows what it knows and what it doesn't know.
Oh, that's a good example. Autistic reasoning. Usually, severe autism does not know what you know. That's not really. That's way beyond what I tried to explain. But at least, if you teach a chatbot some certain discourse rules, then it will not make like too silly mistakes. Okay.
I guess this is kind of a broad question, but I noticed you didn't talk about developing a model of the other person's internal knowledge. And it seems like I kind of think of discourse as that being a fundamental part. Questions being asked are sort of serving the purpose of me figuring out more about what's inside your head. So I was wondering if you could elaborate on.
Okay. So the question is a real like user model. It is done in a very limited way. So if I'm asking about my tax return, that's only what I mean. I don't care, like as a chatbot, I don't care about your whole personality. I only care about your problem, your exact problem. And when you express your problem with taxes, you express it using certain discourse. So my user model is limited just to a particular question. And then I assume that your other question will be totally independent. Like your next question about music will be handled by different bots, which have, for music you can have just play this. It means default, there's no discourse analysis. Or I like this music, my friend recommended me that, what should I, those kind of recommendations. So again, there is a user model, but very limited, very pragmatic to specific purpose.
Yeah, the tax example is a good one though, because I guess I imagine an IRS chatbot would be saying, okay, I'm missing information about whether you're married or not. So that's going to be the next thing in the discourse. And to me, it's kind of like there's a missing piece of my...
Okay. Actually, slot substitution is a very well explored, even for platform chatbots, which I criticized a lot. But slot substitution problem, like pizza ordering, it will come back and ask what size, whatever you want. Those chatbot parts pretty straightforward. So for that, you don't even need discourse analysis. So this stuff is done well, but it's very domain specific. So pizza bot, I mean, good enough. Like ordering, simple thing, ordering, asking for parameters. That is done pretty well. I mean, it's not. What is not done, how can you use like customer reviews in recommendation? So, but if you just give an exact parameters and the bot automatically asks you to fill the slot to get all parameters, that is done. I mean, that is not a question these days.
1 minute.
Yeah, okay.
So maybe one last question while he's backing up his computer.
Yes.
Some narrow domains, and I've worked in a few of these, you can actually get a system that is very semantics heavy, so it can even represent the question as a semantic parse that can be executed to deliver the answer. And it's a generative approach where it can go to a database and pull information out.
Oh, that's one option. I have one option of this chatbot, just pure natural language to SQL language. That is straightforward. That doesn't require discourse analysis. Even if like multiple tables, you cannot handle, this way you cannot handle complex discourse. It's just give me all constraints, I'll combine them, convert from natural language to logical form without. So for that also discourse analysis doesn't help for database. But that's a very specific use case.
All these things could be combined to have a more powerful...
So system needs to figure out, okay, this is a database query, so let's just convert to database.
Well, thank you very much for coming, Boris.